Hello everyone. Once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed about stress and different types of stress. Today we will discuss about another major concept of this chapter, that is strain. So what do you mean by strain? You must remember one thing, wherever there is stress there will be a strain. So do you remember stress? Yeah, stress is the restoring force developed per unit area within a body when an external force is applied to a body. Okay, so whenever an external force is applied to an object, a restoring force is developed within that object in the opposite direction. And that restoring force developed per unit area is known as stress. So what do you mean by strain? See, whenever a force is applied on an object, there will be a change in the dimension of that object. Change can occur in any dimension. Change may occur in the length of the object. That means whenever we apply a force on an object, its length may change, or its volume may change, or its area or shape may change. So change can occur in different dimensions of that object. That change produced in an object as a result of the applied force is known as strain. Okay, so strain is a measure of deformation. Deformation means change, representing the displacement between particles in a body to a reference length. Okay, simply we can say strain is the effect of stress on an object. It is the measure of deformation produced in an object as a result of the applied force. It tells us how and what changes take place when a body is subjected to strain. Mathematically, strain can be calculated using this equation. Strain is equal to change in dimension by original dimension. Dimension means length, breadth, volume, mass, area, all are dimensions. Okay. And what is the unit of strain? Most interesting fact is that it is a dimensionless quantity. Dimensionless means it doesn't have any unit because it is the ratio of two similar quantities, isn't it? Okay, and we will understand this concept in our coming sessions. So what is strain? Strain is the effect of stress. It is the measure of deformation produced in an object as a result of applied force. And mathematically, strain can be calculated using this equation. Strain is equal to change in dimension. Strain is equal to change in dimension by original dimension. So there are three types of stress, isn't it? Accordingly, there will be three types of strain. The first category of stress we discussed in our previous class was longitudinal stress. So corresponding to longitudinal stress, there will be longitudinal strain. So what is longitudinal strain? Longitudinal strain means it is something related to change in length, isn't it? So longitudinal strain is calculated using this expression, change in length by original length, because the general equation to calculate strain was change in dimension by original dimension, and in the case of longitudinal stress, change occur to the dimension of length. So longitudinal strain is equal to change in length by original length, delta L by L. Delta L means change in length and L is the original length. So how will you define it? Longitudinal strain is defined as the ratio of change in length to the original length. If you look at the expression for longitudinal strain, you can see in the numerator we have length, in the denominator also we have a quantity in length. So it is the ratio of two similar physical quantities, isn't it? So what will be the unit in numerator? In the numerator the unit will be meter, and the denominator also unit will be meter. So both the meter will cancel. That's why we will say that strain is a dimensionless quantity. It doesn't have any unit. So longitudinal strain is calculated using this equation, delta L by L. Okay, so types of strain. First one is longitudinal strain. It is the change in length to the original length of the body. Okay, due to the longitudinal stress. Children, this is not strain, this is stress. So just correct it. Longitudinal strain is defined as the change in length to the original length of the body due to the longitudinal stress. If we apply a longitudinal stress to a body, either the body elongates or it compresses. Right. This change along the length of the body. This change in length is measured by longitudinal strain. Okay. And longitudinal strain is delta L by L. We had already discussed that. Now next type of stress was shearing stress. So corresponding to shearing stress we have shearing strain, and shearing strain is the measure of relative displacement of the opposite faces of the body as a result of shearing stress. Okay, so here by looking at the figure we can understand about shearing stress. Here I told you, whenever we apply a tangential force like this parallel to the surface of the object and keeping the lower surface fixed, what happens? There will be a change in the shape of the object, and the stress developed is the shearing stress. Corresponding strain will be shearing strain. And how will you find out the shearing strain? So here this angle theta represents the shearing strain, because this theta represents the displacement, relative displacement between two opposite faces of the object, and this displacement occurred due to the application of that tangential force. So this theta is considered as the shearing strain here. And how will you find out theta? If you consider tan theta, from this figure, what is tan theta? Tan theta is opposite side by adjacent side, and here opposite side is delta x, adjacent side is L. L means length of that block. So tan theta is delta x by L. And for very small angles, tan theta can be approximately considered as theta. That is small angle approximation. Okay, so if the angle theta is very small, tan theta is approximately equal to theta. So here theta is equal to delta x by L, and this theta itself is the shearing strain. Okay, so here in this equation, that is delta x, we can consider this as delta x. So shearing strain is equal to delta x by L. Now another type of strain is volume strain. Volume strain is defined as the ratio of change in volume to original volume as a result of the hydraulic stress. You know, volume strain is corresponding to the volume stress, and volume stress brings about a change in the volume of the object. So volume strain will be the ratio of change in volume to original volume. Okay, so that's all about different types of strains corresponding to different types of stress. Now we can discuss the most important law of this chapter, that is Hooke's law. So Robert Hooke was the scientist who gave Hooke's law. Hooke's law states that within the elastic limit, stress developed is directly proportional to the strain produced in a body. That means if the stress applied on an object increases, strain also increases correspondingly. This is Hooke's law. Okay, stress is directly proportional to the strain produced in a body within the elastic limit. And what is this elastic limit? That we will discuss in our coming sessions. So according to Hooke's law, if strain increases, stress will also increase, and vice versa. Hooke's law is applicable to all elastic substances, but it does not apply to plastic deformation. That means Hooke's law is not applicable to plastic substances. And how can we express Hooke's law mathematically? Mathematically, Hooke's law can be represented as stress proportional to strain. That means stress is proportional to strain. So to remove the proportionality symbol, a constant is added, and here the constant is K. Stress is equal to K into strain, where K is the proportionality constant and is known as modulus of elasticity. Okay, so Hooke's law gives us an idea about the constant modulus of elasticity. Now, just look here. If we plot a graph between stress and strain, what you will get? So just plot stress here. along the y-axis and just plot strain here along the x-axis. And what will be the graph between stress and strain? The graph between stress and strain will be a straight line starting from origin, because stress is directly proportional to strain. And if you take the slope of this straight line, what will you get? Slope of this straight line gives you the ratio stress by strain, isn't it? Because slope is equal to y by x. And what quantity is plotted along y? It is stress, and quantity plotted along x-axis is strain. So y by x ratio is equal to the ratio stress by strain. And what is the stress by strain? From this expression, what is stress by strain? Stress by strain is equal to K, isn't it? From this expression, K is equal to stress divided by strain, right? So the ratio stress by strain is equal to K, that is modulus of elasticity. Hence the slope of stress strain graph gives us the modulus of elasticity K. Okay, so the Hooke's law graph will be a straight line for elastic substances, and the slope of stress strain graph gives us the value of modulus of elasticity. So what is elastic modulus? Elastic modulus is a ratio of stress and strain, and it is a characteristic value of each material. This means gold will have a specific value of elastic modulus, and rubber will have a specific value of elastic modulus, etc. So the elastic modulus of different materials are different. And how will you find out that elastic modulus? Using this expression, K is equal to stress by strain, where K is elastic modulus, or it is also known as modulus of elasticity. And corresponding to three different types of stress and strain, we will have three different types of moduli of elasticity. And we will discuss about the three types of modulus of elasticity in our next session, along with a stress strain graph. Okay. So that's all about stress and strain and also modulus of elasticity. With this, I am concluding today's session. Notes of the topic and YouTube video have been uploaded. Just go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.